All right, welcome back. In this video, we're going to talk about input and output as it relates to FBX. It's going to be kind of divided into two sections. We're going to be taking the mocap biped 3 rigs and exporting them to FBX as a first step, just so we can have some FBX on disk, so we can use those when setting up the crowd sim. This is, I could have just provided the files, but I think it's kind of worthwhile to see how FBX exporting works. And also it'll give you guys some FBXs to work with in the next video, where we're actually taking the FBX and importing them for CrowdSim. So here we have our walk cycle. I'm going to turn off in place animation so I can use locomotion. I'm going to drag and drop, rename this to run, and change this to run. The walk cycle is set to male R002, which is just one of the nicer walk cycles. It loops nicely. So, okay. Then if you saw my video on exporting USD, the first thing you would have seen, the next step would have been to drop down a top network. Unfortunately, we don't. Our FBX export node doesn't. We don't have an equivalent in our top network at the moment. So we have to kind of go back to our old style or legacy version of tops, which is ROPS, and where the FBX operator does exist. So I'm going to come in here, I'll rename this walk, and let's go through setting this up. So frame range. The walk cycle is 26 frames long. I just happen to know this. The export parm is basically, you want to pick the root of the rig. So in my case, it's this master node. And we can verify that this is the case by coming back to our mocap biped 3, which is, a digital asset, diving into it, and here's the root of that rig. So we come back here, we have that rig, and 26 frames. Let's rename the file path. So I'm going to put in a subdirectory from my hip directory called FBX. I'm going to name it hip name, which is the name of the current file, and then $OS, which is just the name of the current node. Might want to name your hip file at this point to something intelligent, and put it in a good place. Then we're going to come down here, and there's some options we want to turn on. So force skin deform export animation takes, clips takes. I'll call this one walk, and I'll set the frame range 1 to 26. A little bug that I found is the first time I set this up, I was like, well, for convenience sake, I'm just going to make a channel reference from here to here, this parameter. Unfortunately, that doesn't work. If you do that, the animation won't write out properly. So just a heads up not to do that. I'm going to log a bug on that, so hopefully that problem goes away soon. But just a kind of gotcha to be aware of in the meantime. Okay, so I'm going to drag and drop this, copy this, so Alt and drag, rename this to run, and we should be in good shape. Okay, so we have these two nodes. I could just come up here and hit save to disk, and I could cache these guys out to disk. Oh, I forgot something. The run cycle is not 26 frames, it's only 17 frames. And we have to write this out manually, both of these parms. Okay, so we could write these guys out to disk by hitting save to disk, and that's simple, straightforward, nothing wrong with doing that. If you had, say, like many of these that you needed to write out, so say you had like 100, you may want to leverage your render farm to do that, and that's where tops would be handy. And even though these nodes only exist in ROPS, we can still take advantage of them in TOPS. So I'm going to come over here to the top net, and I'll make what's called a fetch node. And so this is great. This is a way to fetch a ROP from a ROP network and use it in TOPS. So rename this to walk. Great. And I'll make a copy of it, alt copy, alt drag rather, and rename this to run. Have that point at the run. And then I'll plug this into a merge node. Great. And hit, and then we can execute this. If you have deadline, you can use a deadline scheduler to render it on your farm. If you're using Tractor, which is Pixar's scheduler, you could send it to the farm via Tractor. And if you're using SideFX's HQ, then you can use that as well. These are all options to render on farms. But for this example, I'm just going to render with our local schedule, so on the local machine. So I'm going to right click and choose cook selected node, and it prompts me, it says, I need to save the current HIP file. So save your HIP file out, name it intelligently before you execute this. And we should be good to go. Now that ran a bit quickly, so I don't know that actually, I think I may have already written some FBXs to disk. So I'm going to delete this node's results from disk. Delete this node's results from disk. Just rerun it, make sure I have the proper thing. So right click, cook selected node. Yeah, so it's taking a second to run. And looks like we're in good shape. Okay, so now that we've written these guys to disk, let's verify that they wrote out okay. So I'm going to come over here and go to import, import filmbox FBX. There's probably one thing that I forgot to do. So I got you over here. I bet you I didn't rename the run clip, and I didn't. I just named it as walk. So I'm just going to quickly regenerate that, and I'll do that here. No need to go to the top network. All right, so hopefully that wrote out properly. Now let's import this FBX. So go import filmbox FBX. I'm going to pick the run clip, hit accept, import, and let's see what we get. I'll turn off the display of these guys. And okay, let's see. And the animation did not import. Interesting. That's curious. Let's see if I can figure out why. Master, 26 frames. Good. Exporting clip. Save it out to disk again. And you know what it is? I think the display flag may have to be on for these guys to work. Let's double check, which may be it's a little weird, but let's double check, see if that's actually the case. I'm gonna hit save on this one, hit save on this guy, and let's come back, delete this, and let's try importing these guys again. Yeah, and now it works. So that was the issue. In order for the animation to be written out correctly, you need to have the display flags on, and if they're not set, it won't export properly. Just a little kind of hint to kind of mitigate that problem, because remembering to turn on these display flags all the time is kind of a pain. There's a little bit of an H script that you can set to kind of do this automatically, and you can have it run every time you do a render. So I'm going to just show you this very quickly. I'm going to, let's see, Windows, and I'll see if I can, let's see, Python shell, HScript textport. HScript is kind of like Houdini's old style scripting language. Most of this is done through Python these days, but it still has its uses. So I'm going to go offset. This is the name of the command I'm looking. I'm going to get the help on it, so I can type help offset. And then it gives you an example of the usage. So what I want to do is set the display flag to on, which is this D flag. If we scroll up, we should be able to see it. See D. And the syntax for this is, let's see. I'm going to go offset. I'm looking at this syntax here, -D on, and then the node we want to turn on. So I'm going to grab this walk node, and let's turn that on. Yeah, so that turns on. Great. Another thing you can do if you don't want to specify the nodes specifically is you can just use an asterisk. And it'll turn on the display of all the nodes. So just to see that again, offset -D on obj/asterisk or wildcard, and all those display flags turn on. So yeah, we can modify these ROPs right here. So I'm going to select both of them, and both of them have this. I'll drag this over here. Both of them have this scripts tab, so we can come here to the scripts tab and just type this in. So just go offset, or if you want to copy it, you can, /obj and then asterisk. Right? Okay, so I'm going to grab both of them too, and I will hit save to disk. It should write both of them out, and I'll just do it explicitly. Get paranoid. And come up here, and let's try importing this again. So, yeah, so I'm trying to, include my kind of mistakes as I go, because if I'm making these mistakes, chances are you're going to make them too. So it's just nice to not have any surprises. So, yep, this looks like it came in okay. Let's bring in the run cycle, see if that came in okay. Import filmbox FBX, grab the run, hit accept, hit import. There we go. And that looks like it's bringing in the walk. So did I do something incorrect? Let's take a look. Go to my run, and I did. So my run is looking at my walk cycle instead of my run cycle. Easy enough to fix. I'm going to come over here, run cycle, grab the master node, save it out to gain, and come back up here. I'll delete my import of the run cycle and then import my run cycle again. And with any luck, we should be in good shape. So yeah, there we go. Perfect. Okay, so this is basically the end of this video. This is basically talking about how to write out the FBX. In the next video, now that we've written out the FBX, we're going to talk about how to import it for use in a crowd sim. Okay, we're back. In our previous video, we were exporting some FBX from a couple of rigs, namely mocap biped 3. I just took what we had in the previous file, put it in a network box. So from here, we should be pretty much ready to go. I'm going to click on the agent node or the agent shelf button and go find the FBX that I wrote out on disk. So I'll grab that walk and I'll call it the agent name, mocap biped 3, yeah, and we'll call it walk, I'll hit OK. All right, so let's display what we got. Okay, so there's our agent. It's coming in okay. But there's a kind of important gotcha here. So I'm going to display the rig that we exported this from. And this is the agent that we've created. And you'll notice that there's an issue. The agent comes in super, super small. And the reason why is because if we come onto this agent node, there's this option for convert units. So what this means is, so a package like Maya, in that package, the units that are kind of people generally use are centimeters, and in Houdini, well, the one unit is 1 centimeter, I believe, in Maya, and then in Houdini, the units are meters. 1 unit is 1 meter. So there's a scale difference that goes on here. And because of this, the agent is kind of, it's in units. It's in, modeled or created in this kind of meter scale. So this create agent by default has this convert units toggle turned on. And if we turn it off, you'll see he gets bigger and he matches. So the thing to kind of be aware of here is your units. So if you're writing an FBX out of Maya, chances are you're in centimeters. So you'll want to have this turned on so that when you bring it into Houdini, it converts it to Houdini units or meter scale. So that's a kind of important gotcha you gotta look out for. Another approach we could have made was we could have there's an option on the FBX ROPS to where is it? Convert units. So you could toggle that on, and it would convert to this other unit space that FBX typically uses. But for our sake, we're just going to remember to keep this convert units toggle turned off. You'll need to pay attention to it in the what do you call it, agent clip as well. You'll have to toggle it off there as well, or else you'll get weird results. So, okay, with that, I'm going to add add a clip. Okay, select agent to add clip to. So I'll select, hit enter. I'm going to do it from FBX, and I'm going to grab the run clip, and I'm going to name the clip run. Hit OK. And all right, look, I made a little mistake here. So this is just kind of peculiarity of how the add clips shelf button works. If it kind of keys off the display flag, so I had the display flag up here, and because of that, it assumes there's nothing underneath it. So as a result, it makes this other branch. To kind of fix this, I'm just going to delete this node, come down here to Alt or Out, and then I'll hit Add Clip and select my agent, hit Enter, pick my FBX, which is Run, and I'll name it to Run, hit OK, and we're now in good shape. Okay, it doesn't make the extra node, and it just adds the parameter to this existing agent clip node. We have to turn off convert units for the run cycle as well. Once we're done to do that, we're in good shape. Okay, let's come down here to the agent prep. The agent prep looks like it's auto-populated. This is more than likely because the rig that we exported is based off mocap biped 3, and by default, the agent button, when it sets up all of these nodes, is looking at these bone names, and if they kind of match this kind of default rig, it populates it. don't count on it doing this for you. If you're creating a rig in another package and your bones are named differently, you'll have to fill this in yourself. There's a drop-down menu, so you can pick the relevant bones and put them in place. Yeah, so this is just one of those steps you'll have to be aware of. Particularly important are ankle and toe joint, because you need these to set up foot planting in the foot planting channels. And once you've set all this stuff up, you can save a preset. So you can, where is it? Save preset. That way you don't have to do it over and over again once you've established this kind of setup for the character once. Then you can just use that preset and you don't have to manually enter it over and over again. Or conversely, if you're setting things up with a Python script, maybe you're making a shelf tool that incorporates some of these steps all together. You can have that script populate these fields for you. So another consideration. All right, while we're here, I'm going to click on Create Foot Plant Chop Network. Give ourselves that. And this should be good to go. So, yeah, let me just double check my clip stuff. Good. We want to convert to in-place animation because we're going to be using locomotion. So we got to pick our locomotion nodes. So hips, and for orient, I'm going to use right leg up to right leg. Okay, groovy. So that's taken care of. I can come back up here and let's create a grid to populate this agent here. So let's do that. Okay, so I'm going to come up here, hit the populate button. Where are we? Populate. Select the terrain. Great. Come back to the viewport, hit enter. And there we go. We got our sourcing as we'd expect. So that's good. I'll bring this source node over here. Now I'm going to simulate. So hit select crowdsource, it says, and hit enter. Pick my cycles. I'm going to do walk and run. Accept. Groovy. And once I've done that, we can add our terrain for foot planting. Select terrain, press enter. Great. And then I'm going to turn on a few things here. I'll do enable foot locking, show guide geometry, adjust hips. Yeah, I think we're good there. I'll bring it back to the origin. I'm just going to make my terrain a bit bigger. Come into my grid object, and I'll change the size to 100. 100. Good. Okay, and let's play it forward, see what we got. Okay, fairly straightforward. Let's just do a quick transition to make sure the run's working. I'm not going to use a transition graph. I'm just going to use vanilla old default transition. So it'll look a little janky, but if you want more information about that, go take a look at the locomotion section or the locomotion videos that I created. I'm going to trigger this based off of time. I'll do 2 seconds with no random offset. Here we go. And let's play this back. Okay, so that doesn't look like it's working correctly. And that's because I have not turned locomotion on in my states. So both these nodes have to churn them from in place to locomotive. And now our foot locking should work. And it does. Okay, so that's how you kind of import FBX and use them for your crowd sims. I will it kind of concludes this section on IO for crowds. Yeah, and I will see you in the next section.